Okay, 5.3. Sum and difference identities. Yikes. I'm gonna just try to write that again. Alright, we're gonna have a bunch of formulas here that you're gonna need again, okay, so make sure you know these. The cosine of u plus v is equal to, and cosine of u, cosine of v, minus sine of u, sine of v. The cosine of u minus v is equal to the cosine of u, cosine of v, plus the sine of u, sine of v. The sine of u plus v is equal to the sine of u, cosine of v, plus the cosine of u, sine of v. The sine of u minus v is the sine of u, cosine of v, minus the cosine of u, sine of v. The tangent of u plus v is equal to the tangent of u plus the tangent of v all over 1 minus the tangent of u times the tangent of v. And then the tangent of u minus v is equal to the tangent of u minus the tangent of v all over 1 plus the tangent of u tangent of v.
Oh, crap. I'm going to take a little while longer for most people to get this, because I reckon it's long. Just realize we're writing.
U and v need to be known angles. What do I mean by that?
Why does it have to be U and V?
They gotta have numbers.
If I need to know the angles, where do they have to come from?
Pie chart. Circle thing. Circle thing.
Okay, so AKA they need to be on the unit circle.
That's what it's called.
For these problems, to make your life easier, you can convert radians to degrees. Now, I hope that you know this stuff well enough that you wouldn't need to do that, but you can if need be. And I will say, more than just knowing these formulas, these do require you to think more than anything. Okay, and you'll see why in just a minute, but I'm going to let everybody get all this down before I start trying to jump into problems.
Does that say you can convert radians to degrees?
Yes.
I'm just literally trying to read it.
Yeah, that sounds like a whole TCAP.
I need to just stop.
Sounds so good.
If y'all would like to try them, I got the Reese's that have marshmallows on top.
I was so
I don't know. I literally just got one bag of them. They're a little weird in my opinion.
I'll look at that first. I think I might try it.
Watch your head, Melcher. Two eyes. You want to try one? They're a little weird in my opinion, personally, but
I don't think
do you want something different?
I do not.
Like all the normal stuff. I also have Reese Bunnies, Hershey Kisses, Rolos.
Did you get your candy
Do
from
some
the
take
Dollar
five.
Tree?
No, I don't.
I'm a bunny.
Go to the Dollar Tree.
It's alright,
Candy,
but,
like,
you know,
I thought the marshmallow was a little weird.
yeah.
like a little too sweet.
Honestly, if I wanted to have something like that, I would probably at least smother it in Jiffy, melt it, and then put it on.
Bunny down, bunny down.
I know, I realized you didn't hear.
All right, do we all have this? So we can move on to problems.
Oh, no, yeah.
Okay, let's do that quickly. I need a bunny too.
Oh, I'll make one. I don't have more. Well, how long is tennis practice gonna be, or like from what time?
It's an hour, 3:30 to 4:30.
Okay, I can be there for 30 minutes.
I know some people have other stuff, which is fine. I just trying to get some extra practice in since we've not had a practice in a long time.
Well, we boys should play at the same time. It's within our records.
And we got denied the ability to play in a tournament, so that makes me really sad.
Why?
We were told no.
No.
Is it COVID?
Because we shouldn't spend 12 hours in one day playing tennis. That's what it is.
12 hours, holy frick.
It would basically be we'd be gone that long.
Like during a full day?
I
It's
think
not gonna be worth it then.
All right, we have all this.
8 a.m. to 8 p.m.
The most interesting thing I've experienced over
We did it
spring
once,
break
just kind of.
was I was FaceTiming Becca, and the entire time she had like a pencil or a knife. She was stabbing a box, like a chocolate bunny box, as we were talking. And it was super intriguing. But at the same time, I was like, why are you stabbing a box? She was like, I don't know. Kind of, you know,
It's kind of concerning.
How
I'm
many
practicing
hours does
with
that
very
problem
concerning.
take up?
Oh my gosh, I can't even touch it.
I mean, if you stack it like left to right and then you go below it and keep going, then it would be like 3-4 lines. Well, if you do your fractions on 2 separate lines, then double that. But if you're gonna do it as individual pieces broken up, it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. 10 lines, but are all fractions, so 20 lines. So you may want to go like left to right and then go down and then left to right again. Just advice. Okay, so these problems say to use a sum or difference identity to find the exact value. Okay, so the problem initially gives you something that you don't know the answer to. Okay, so you're going to use the sum and difference formulas up here to solve the problem. So the first one is going to be the tangent of 15 degrees. Okay, so we want to rewrite this as something we know. Okay, obviously it doesn't give us something that looks like this. So I need to figure out, okay, what values do I know so I can rewrite it in terms of that and then use the formula, identity, whatever you want to call it. Okay?
Yes.
It'll make more sense once you see it, I promise.
Root 3 of 3. Root 3 of 3. Root 3 of 3.
Okay? We're dealing with 15 degrees, so I'm going to use, and there are plenty of options, okay? I can use really a variety, but I'm going to use the tangent of 45 minus 30. Okay, because would you agree that the tangent of 45 degrees minus 30 degrees is the tangent of 15? Yes. Okay, so now I have values that I do know. I know what the tangent of 45 is, and I know what the tangent of 30 is. Okay, so this is going to be my u, and this is going to be my v. Alright, I guess I need the formula. I'm going to try to leave it here for just a second. Alright, so we need this tangent of u minus v. What?
Do we have to use u and v?
No. I'm just doing it to show you with the formula that's written here. I'm not going to usually write the u and the v. Alright, so following the formula, I'm going to have the tangent of 45 minus the tangent of 30 over 1 minus the tangent of 45 times the tangent of 30. So what is the tangent of 45? 1. Tangent of 30? Root 3 over 3. Okay. And I can give you unit circles when we have the quiz, just remind me. Okay, over on the bottom, 1 minus, it's going to be 1 times root 3 over 3. Okay, so just this simplifies to 1 minus root 3 over 3 over 1 minus root 3 over 3. Or sorry, wait. On the bottom, it's supposed to be a plus sign. I miswrote it. I was like, wait a second. Nope.
We have to multiply by the conjugate.
Yep. Okay, multiply by the conjugate, so I'm going to try to do this, write this step up here, and then I'll write the answer down there. So 1 minus root 3 over 3 over 1 minus root 3 over 3.
1 minus. Oh,
Okay, because I need the opposite of the bottom one. So on top, what does that leave me with?
Root 3 over negative root 3 over 3 minus root 3 over 3.
Was it just 1 minus root 3 over 3 minus root 3 over 3 minus root 3 over 3?
What? No, it's that.
No, I'm stupid because I took the stupid things times it. I'm special.
That's what you should have on top. 1 minus 2 root 3 over 3 plus 3 over 9. Okay.
Bad one, but it
What? Probably have too many straws.
And then on the bottom, what do I have? So I have a difference of squares on the bottom now. So what does that leave me with?
What is what is root 3 over 3?
is it 1 minus 2?
That's what I said.
Okay, it's a difference of squares, so it's a squared minus b squared. So now I'm going to simplify and get a common denominator. Since these simplify into 1/3, I'm going to get everything in terms of 3's for the denominator. So I'll have 3 over 3 minus 2 root 3 over 3 plus 1/3 all over 3 over 3 minus 1/3. Okay, and some of this you might be able to kind of skip when you're doing it. Okay, do it all in one step. I'm just trying to show out, just since we don't like fractions usually, and unfortunately these problems do end up with a lot of fractions. So, the tangent ones do at least. I mean, like yes, the sine and cosine ones can have fractions, but they're all on top, so it's easier to deal with. So I usually try to be nice and not give a ton of tangent ones. Alright, so then on top, this is going to simplify into 4 over 3 minus 2 root 3 over 3 all over 2 over 3. So on top, I can combine this to be 4 minus 2 root 3 over 3. I can multiply by the reciprocal, okay, because I'm dividing by a fraction, so times 3 over 2. 3's cancel. And what else do you see that I can do? I can take a 2 out, okay? Both of these pieces have the ability to take a 2 out, so I can remove the 2. If these didn't both have something that was a factor of 2 or a multiple of 2, I could not do this. Okay? So that one's going to go away, and this one is going to now be 2. So my final answer will be 2 minus the square root of 3. All that work for such a simple answer. It's a great day, isn't it?
No, I just got back. I don't want it.
But I do have to say, if you can do the tangent ones, I mean, outside of just having to know the formulas, if you can do the math of a tangent one, you can do any of them. Because the math on the other ones is a lot easier.
You always say that, and I always do the hard one, and I don't do the easy one.
Well, Allison said I should start out with the hard one. So she always tells me. So I started out with the hard
Yeah, but
one.
maybe not when we're coming back from break.
All right, well, let's get a little easier then. How about that? Sound good?
That was the first problem. That was problem 1.
You realize there's no R2D2s on it. There's your base, no R2D2.
That took up like half of my whole week.
All right, the next one is the cosine of 75. Okay, and on the last problem, just for like reference, I could have done the tangent of 135 minus 120. Okay, but as a general rule, I would say to use the stuff that's easy, like 45, 30, something in quadrant 1, because all your values are positive. Okay, because as you go into other quadrants, I mean, there are going to be some where you have no choice but to do that, but as you go into other quadrants, you end up with negative signs that then you have to keep track of those on top of everything else. So, just my recommendation. All right, what do we think could be used here for the cosine of 75? Two numbers that can be added together or something that can be subtracted.
30 and 50.
30 and 45.
30 and 45.
That's what I said.
Let's see. Let's mix up the color. Purple. All right, so the cosine of 45 plus 30. Okay, and it doesn't matter which one goes where. All right, so our formula, just to go back and look really quick. Okay, we're doing the plus one, so it's going to be cosine of u, cosine of v, minus sine of u, sine of v. Okay, so it's both cosines minus both sines. Okay, you'll notice with cosines, okay, just a quick kind of hint here. With cosine, the sign that goes over here is opposite. With sine, the sign stays the same. Okay, so things like that, look for little like clues like that. With sine, it does not have its own personal buddy. Okay, it has like its cousin with it. Okay, rather than its sibling, it's got its cousin. I don't know. Just kind of think about, find a fun way to remember which one's which. That will help you. Okay, so we're going to have both cosines and then both sines. Okay, so we have the cosine of 45, cosine of 30, opposite sign, so minus the sine of 45, sine of 30. So what's the cosine of 45?
Is it
Root 2 over 2. Cosine of 30?
1/2.
Nope.
Root 3 over 2.
Root 3 over 2. Minus sine of 45.
Root 2 over 2.
Sine of 30.
1/2.
Okay, so over here, I've got, what does this left side give me?
Special magic.
Root 6 over 4. 4.
I was thinking if I could trick you. I was thinking I was going to make you think twice about that. Okay, root 6 over 4. Okay, we have to multiply the top and the bottom. Minus, over here,
Root 2 over 2.
Root 2 over 4.
haha, root 2 over 4.
What's that?
Now, what does that give me? Wrong.
Was my-
Can't add and subtract radicals that are not the same. So this gives me the square root of 6 minus the square root of 2 over 4. See, this one's much easier, right?
That's it. Oh, I see.
All right, you ready for a hard one? The sine of 7 pi over 12.
God.
What should I do first? I should convert it.
Oh, I was just joking. I guess.
7 pi over 12 times 180 over pi. Pi's are going away. Oh, goodness. Just going to tell you, this is 105 degrees. Okay. Just pulled that out of my head.
I did it too.
No, I didn't. I looked at my
I didn't do it
paper.
that way.
Too smart.
I looked at my paper. It's fine. So, good job. Okay, so I can think about this now as the sine of 105 degrees. Let's see, what color this time? Orange?
Yellow, bright yellow, black, neon yellow.
Okay, so how could I break this one up into known values? Think about some values that I know that would add or subtract to give me 105. Do we know 15?
No.
So we know like 30, 45, 60.
What about 135 minus 30?
That works. So the sine of 135 minus 30. Okay, we agree that that gives us 105.
Sure.
Okay. So this is a case where we can't necessarily use something in quadrant 1 because it's not going to work. Okay, on occasion you might get lucky and it will,
We
but
just do 75 plus
do you know 75?
I don't know. 75.
Okay. So somebody tell me what goes here for the formula.
So it's going to be negative root 2 over 2.
No, tell me the formula actually written out.
It's sine.
Oh.
It's the sine of 135.
And the cosine.
And then cosine of 30.
This is going to be.
No, it's gonna be minus. And then it's gonna be the cosine of 30. Or
Cosine
yeah,
of 135.
Shut up, dude. It's
Sine
sine 30.
All right, what is the sine of 135?
Negative root 2 over 2. Or just root 2 over 2.
Just root 2 over 2. So you're on the top. Cosine of 30.
A half. No, it's yeah.
Root 2 over 2.
Cosine of 135. Negative root 2 over 2. Sine of 30.
Half. No. Yes. Ha ha ha.
Okay, so again, make sure you keep up with the fact that these things are grouped. Okay, I am going to end up with 2 negatives here, so just make sure you're paying attention to those signs. So on the left parentheses, what do I have?
6 over 4.
Square root of 6 over 4. 2 negatives are going to cancel, giving me a plus, and then over here I have
Root 2 over 2 over 4.
Oh, you done good.
Same answer as last time.
Nope. It's a little different. Okay, a good hint is most of your answers are going to look like this. Okay. Now, I will tell you that this section works both ways.
I don't want to reverse it.
Okay? Where instead of it giving you something like this, it flips and gives you this, and you have to combine it. Now, I personally think
Oh,
That's a
that's
lot
really
easier.
gives us the bottom number.
I was like, how does that work? Just like trial and error until you get it. No. Okay. We are gonna do one more, and then I'll give you a few of these to work on. Okay, and then tomorrow we'll do the reverse. We'll do the super easy stuff tomorrow. Okay, and you'll have time to finish up like the rest of your problems because we've literally only got like a few problems left.
Actually, do we have notes?
And then we'll probably prove an identity as well tomorrow.
Do we have notes ready?
I don't think so.
Wait.
That was a long time
That's
ago.
not good.
I remember Friday.
The sine of minus pi over 12.
Friday had a bunch of questions.
What is Friday?
It's a problem.
Okay, so what do I do with the minus pi over 12? Okay, yes, I'm going to convert it. Just trying to focus real
That's
quick.
not bad.
Alright, I'm going to convert it. So, minus pi over 12 times 180 over pi. Pi's are going away, so I'm left with what?
Just go ahead and say 15
Yep, negative 15.
Do you have to convert it?
Okay, so I'm now working with, well, do you know what the increments of pi over 12 are equal to?
I'm assuming it's 15. Wait,
Yes, but do you know what their values are equal to?
no.
Yeah, so we wouldn't be able to do that.
What if you like subtract the
6
radians
pi
from each other?
12. That would give you,
Well, that would give you pi over 2.
I created rice spicy chicken.
6 pi over
Which
12.
then, yes, you know that, and you wouldn't have to do anything. They're not going to give you one
I've
that
already
easy.
had it probably at least 27 different times, and I still want a spicy chicken sandwich. No.
Alright, so now I'm dealing with the sine of negative 15 degrees. What do you think we need to do with this one?
Uh,
30
Sine
minus 45.
30
Add
minus
360
45.
to it.
Can't do that.
Add 360.
Add 360.
No way, I'm right.
Okay.
Nerds.
So this would give me the sine of 345. Okay, we need the positive angles. Can't have the negative ones. Okay, so what values do I know that can give me 345?
So good.
Like 330 over there.
360 minus 50.
Minus.
300 plus 40.
Yeah, 340.
Yep, 300 plus 45.
360 minus, no, you're taking 15. Never mind.
Alright, so we've got then the sine of 300 plus 45. Okay. What is the formula written out for this one?
The sine of 300 plus the cosine 45 plus the cosine of 300 cosine the sine of 45.
Okay, and then what is the sine of 300?
Can we not subtract angles from the angles to like,
What do you mean?
or is it just because we couldn't go below 360? Or 3, yeah.
Because we don't know 15.
I don't know.
Well, we have negative 15 here, but for the upper number 6, we have 135 minus 30. Or is that because it still gives us a positive value?
The angle you start with can't be negative. Alright, so the sine of 300,
Is that in negatives or derivative?
I think so. Cosine of 45,
Root two.
One half.
cosine of 300,
It's gonna be negative half. Wait, no, it's
Just
one
a half.
sine of 45.
Root two,
Yeah.
How-
The side simplifies into
Butter on that.
Negative root 6 over 4.
negative root 6 over 4 plus.
Root over
Okay, so I will tell you, I'm fine with you leaving your answer like this, but I suspect your book will write it as the square root of 2 minus the square root of 6 over 4. Okay, so notice the square root of 2, square root of 6, and 4 tend to show up a lot. Bless you. Go like Lysol the wall over there real quick.
I thought I didn't have to do it. I thought I
If
was
he has the
talking
Rona,
to
we're all getting it. I hope you know that.
I don't. I can still taste stuff.
All right, cool. Any questions? Sweet. Then at the present time, okay, and like I said, I will add on more tomorrow when we finish the section, okay, when we do the opposite.
Oh, no.
Dude, I said that to Ryan when we were at the
Yeah,
Utah
Ryan-
beach, and he was like, bro.
Ryan was like, dude, you should watch
3,
this. No. How many times do I have to feed you?
5, and 7.
All just people blindfolded from cave.
Okay, and we'll do the reverse tomorrow, improve one identity, and be done.